Okay, we're going to start this 8-4, simplifying rational expressions. And when we simplify a rational expression, what we are doing is we're technically simplifying a fraction. That's what rational means. But what we are going to look at is, like I have down here, is when this rational expression is something that is a polynomial over a polynomial. So the two goals that we have is to understand why rationals simplify, and that's going to be like a fraction lesson. We have to understand why and how fractions simplify for the rest of this to make sense. We can't just take shortcuts anymore, like simplifying 2/4. We have to know why 2/4 simplifies, and it makes so much more sense from going on out, because then we're going to use the skills that we have to simplify, meaning that why do fractions simplify? How do we factor? That's another skill that we're going to have to be able to do. And what do we have to do and put all these together to simplify a rational expression? Okay. So when I talk about a rational expression, what that means is, I'm going to show you one. That would be like if I have like x squared minus 5x minus 24, and I have an x squared minus 7x minus 30. Alright, so this is a rational expression, meaning that the numerator and the denominator are both different types of polynomials. But you cannot just start crossing out, and rewrite this as like a negative 2x on the... Okay, it cannot be done that way, because there is addition and subtraction in here. There's other operations than multiplication, because we need to know why fractions work, okay, and how we simplify a fraction. If, let's say, we need to know fractions and how they work. This doesn't work because if I had a 2/4, we all know that that ends up becoming 1/2. But why? Why does that work? Now, it's because when I take and I write this out in its factors, 2 is 2 times 1, and 4 is 2 times 2. Now, because there is multiplication in here, we are multiplying here and here. Now I can simplify out common factors, leaving you with the 1/2. Up here, what we had here, there's no multiplication. So if you don't have multiplication, you cannot start just crossing things out. And why? Why is this? If I have 1 plus 2 over a 2 plus 3, I can't just start crossing these 2's out and give 1/3, because that's not what it's going to equal, because 1 plus 2 is actually a 3, and a 2 plus 3 is a 5, so this answer is actually 3/5 and not 1/3, because you cannot just start crossing out things that are being added to each other. That's why you cannot do that up here. So you need to know how fractions work. So what we have to start doing is we have to start by saying everything has to have multiplication. So your numerator and your denominator need to be factored, meaning that you have to have nothing but multiplication between terms. Then, once you have multiplication between terms, then you can start simplifying and crossing things out, but they have to be the exact same. What I mean by that is, let's look at something that we know how to do. Let's go a monomial over a monomial. We did this back in chapter, I think it was 5. But let's say we have a 5x to the third y over a 15x y to the third. What we do is we factor this all out to get nothing but multiplication between all terms. So we would have a 5 times an x times an x times an x times a y over a 3 times a 5 times an x times a y times a y times a y. And we know that once we have the same factor on the top and the bottom, we can cross them out. Then we bring everything together, and this is an x squared over 3y squared. Now that's a monomial over a monomial. Okay. We know how to do that, so now let's continue this idea. What happens if we have a monomial over a poly, meaning something that has more? So that would look something like a 2x over a 4x squared minus 2x. The common mistake is students just wanting to take and cancel out those 2x's. You cannot do that. Okay? Because there is addition in here. We need multiplication. We need to factor. So the numerator becomes 2 times x, and we need to factor the GCF out of here. So there is a 2 and an x, leaving you with a 2x minus 1. Okay, so then when we factor that, we get 2 times an x times a 2x minus 1. So now, these 2's, this x goes, and we are left with, in the numerator, a 1, and in the denominator 2x minus 1. You have to make sure everything factors. Okay, what have a polynomial over a polynomial? So let's go poly over poly. So let's say we have a 49 minus z squared over a z plus 7. We have to factor. That's why we had that full chapter. Chapter 6 was nothing but factoring. I think it was chapter 6. This numerator is a difference of squares. So this is a 7 plus z times a 7 minus z over a z plus 7. Now you can only cross out like terms. This and this are like terms because there's addition, they're both positive, so it makes no difference if you're adding the z or adding the 7. So when they factor out and they simplify, you get a 7 minus z. Now it can get so much more, it can get bigger. So let's have an poly over a poly. And this is where our factoring comes in, where we have to be good at this. X squared plus 8x plus 16 over an x squared minus 2x minus 24. You have to factor both the top and the bottom. So what we want to get it down to is some factor here, some factor there, here, and here. So what multiplies to get 16? That adds to get 8. And we have ourselves 16 adds to get 8, right? So 4 times 4, 16, and 4 plus 4 is 8. So this would be an x plus 4, x plus 4. And then the denominator, what multiplies to get negative 24, and then adds to get negative 2. That would be a 6 and a 4, 6 and a 4. That would make this 6 a negative, so this would be an x minus 6, x plus 4. Then you can only simplify out like terms. So when those simplify out, you are left with an x plus 4 and an x minus 6. Okay, lastly, we're going to talk about restrictions. And we got to talk about restrictions because there is division in these problems. And because there's division by problems, you cannot divide by 0. Okay? So we have to pick the values that, or find the values that will divide by 0. But first off, let's go through and let's do these couple problems. Let's factor this. 4z minus 12 has a 4 in common, leaving you with a z minus 3. And the denominator has also has an 8 in common. And then you have a z plus 3. Now the 4 and the 8 simplify, leaving you with a z minus 3 over a 2z plus 3. This z minus 3 and z plus 3, they are not identical, so you cannot simplify them out. So, restrictions. You have to go to the denominator, and wherever the denominator will be equal to 0. Okay? So if I would take the denominator, z plus 3, and equal it to 0, by minus a 3, z cannot equal negative 3. So that is my restriction, because if I put negative 3 in there, I'll have 0 in the denominator, and that's not good. So that is the simplified form with the restriction. Next, let's simplify this. 3x minus 3 has a 3, so we're given x minus the 3. Then we have on the denominator an x, and then an x. Oh, no, that numerator is wrong. 1. Okay. So now this x minus 1 simplifies out, so we technically simplified is 3 over x. But my restrictions come from this part of the problem. You have to go to the original and go through the factored form. So that's why you have to show all these steps. So we say when x is equal to 0 and x minus 1 is equal to 0. So we add 1, add 1. So the restrictions on here is where x cannot equal 0 and x cannot equal negative 1. Not negative 1, positive 1, sorry. Because I have to go to the original problem and find where the original problem, when I factor it, where everything is equal to 0. So there's a simplified form and the restrictions. Okay, let's do this last one. Let's factor this. So I'm left with, this would be an x plus 2 and an x plus 5. And on the bottom will be an x plus 2 and an x, I think it would be minus 5. Okay, so when we simplify that, these go away, so I'm left with an x plus 5 over an x minus 5. But the restrictions are when this is equal to 0 and this is equal to 0. So the restrictions are x cannot equal negative 2 and x cannot equal 5, because that would make the denominator 0.